Hello, I'm Mr. Malden, and this is the Middle School Math Toolbox, where I teach you how to become a middle school math master. All right, today we're talking about outliers in data representation. All right, and being able to understand the formula for the limit for the lower outlier and the limit for the upper outlier. So that's what we're trying to tackle today. So we're just going to jump right into this. All right. Outliers, all right? Outliers are values that lie outside most of the other value sets inside the data, all right? So you have an example right here on the screen. If we had a question that gives us quantifiable data and you came up with these numbers right here, 25, 29, 3, all these different data values, all right? You notice that most of them in this set are in your 20s and lower 30s, all right? So you see kind of a cluster of the data. If I were making a box plot, all right, or sorry, a dot plot, it may look like something like this, where you've got, your 20s and 30s, you've got all these dots, kind of clustered right there between 20 and 30, all right, or 20 and 35. All right, but then you've got one that's way over here at 3, and you've got one that's, really far over here at 85, all right? These dots right here are really far away from the cluster of data, and therefore we call those outliers, all right? Which, when you have a data representation like this, it's really easy to identify the outliers because they're significantly below or significantly above the cluster of data, all right? The cluster of data is going to be kind of the concentration of all the data points, all right? So when you've got a visual representation like this, it's really easy to identify them. But identifying them with the naked eye is really still subjective, all right? Which means it's subject to your own opinion. All right, right here, my opinion is that this dot is pretty far away from the cluster, so I think that's an outlier. All right, and my opinion is that dot is really far away from the cluster, and so my opinion tells me I think that's an outlier as well, but that's subjective. All right, we want in math, we don't like subjectivity. We don't like things to be kind of like maybe it is, maybe it isn't. We like to have actual proof. These are for sure outliers because of this objective reason, all right, or this fact, all right? And in order to be able to find outliers, we have these formulas for telling us what is the limit for the lower. So what's the number at the low end that anything below that number would be considered an outlier? Or for the upper, what's the number at the top end that anything above that number would be considered an outlier? All right, you have these actual formulas that you can use to be able to find the limit of the lower and the limit of the upper. And so that's what I want to kind of focus on for the rest of this video. All right, we understand outliers are data points that are far away from the concentration of data, and now we're going to find a way, use these formulas to be able to determine for sure whether these are outliers or not. Okay. So you've got the formula for the limit of the lower outlier is Q1 minus 1.5 times IQR. All right, Q1 stands for quartile 1. All right, IQR stands for interquartile range, which means we're going to have to do some work with this set of numbers to be able to find our Q1 and to find our IQR, because we're going to need those numbers for this formula. And then the limit of the upper outlier is really similar. It's Q3 plus 1.5 times IQR. Instead of subtracting, you're going to add once you multiply those, right? So let's just kind of go through these individually. All right, you've got your data right here. I gave you a little scenario. It says the following data set represents the number of animal crackers found in 7 snack-sized boxes of animal crackers. Determine the limit for upper and lower outliers, all right? So we took 7 different boxes of animal crackers, and each one has a slightly different number in there, but most of them have kind kind of, they're pretty consistent how many numbers of animal crackers they have in it. And every once in a while the machine messes up and puts a fewer amount in there, and that would be considered an outlier, all right? But you have your numbers right here, all right? The very first thing that you want to do with these numbers, always in data analysis, is order these numbers in order from least to greatest. So I'm going to go about right here, ordering these numbers from least to greatest, right? Once I've got the numbers written down, I always want to count how many I wrote down. 1, 2, 3, 4, 5, 6, 7, and then go to my original list and make sure that I had 7 pieces of data. 1, 2, 3, 4, 5, 6, 7. Okay, I've got 7 on my board, and there's 7 in the original question, so chances are I wrote down the right amounts. Then you're going to go find the 5 most important values of data analysis, which are the least, the Q1, the median, the Q3, and the greatest. All right. So the least would be 34. The greatest would be 50. The next number we'll find is the median, so we're going to scratch the lowest and the greatest, and then scratch the next lowest and the next greatest, and the next lowest and the next greatest, until we come down to the middle number. If you have one number in the middle, that's your median. If you have 2, you're going to add those together and divide by 2. That would be your median. Then you'll circle your lower half of data and your upper half of data, right? Now then we need to find the middle of the lower half. That's our Q1. And then the middle of the upper half, that's our Q3. So right now we're trying to find the limit for the lower outlier and the limit for the upper outlier, but we realize that we have to do a little bit of work in order to be able to come up with a Q1 and an IQR. So the first thing we're doing is listing this in order from least to greatest, and then you're finding your 5 most important values for data analysis. Least, Q1, median, Q3, and greatest. And if you've watched some of my other videos on this, I'll call those the LUQ, MUQ, GET, all right, just for short. Then one of my tools is called a data rainbow. I connect the greatest and the least, and I subtract those. 50 minus 34, that's 16. That is my big old range. And then I connect the 2 Qs like that, all right? My Q1 and my Q3, I subtract those. 49 minus 45, that's 4. That's my interquartile range, all right? Just like that. So we've got an interquartile range of 4. All right, now then, we can go look at our question, okay? We need to know the limit of the lower outlier. Once we've found our key information, we can take the numbers that we need and plug them into this formula. So you've got the formula right there on your screen. The limit of the lower outlier is Q1 minus 1.5 times IQR. Well, I'm going to replace the Q1 and the IQR with numbers. All right, I put 45 for the Q1 because 45 is my Q1. All right, so when I found the least, Q1, median, Q3, and greatest, I'm going to take these numbers now and use the correct ones and plug them into the formula. So for this first formula, the lower outlier, I needed Q1, and then I also need the IQR, which is 4, and I'm going to plug that in where the IQR is. All right, so you see, all I did from the formula to here is just plug in the correct numbers for the Q1 and the IQR. And then you're going to do the math, all right? We know that multiplication comes before subtraction, so we do 1.5 times 4, that's 6, and 45 minus 6 is 39, all right? So the limit for the lower outlier is 39. And that means that anything lower than 39 is considered an outlier. All right, so we went through the formula to find out what that objective limit is. All right, this is not opinion, this is fact because we used the formula. And anything below 39 in this data set up here is considered an outlier. Do you see a number that's lower than 39? Yeah, we do. 34 is. So we see that it's well below the limit of the outliers. That's an outlier. 34 is an outlier from this set right here. All right, then we're going to go through and we're going to do the same thing for the upper outlier. All right, but in this case, we need a Q3 and an IQR. All right, so Q3 is going to be 49, and then our IQR is still going to be 4. All right, so we're going to plug those into the formula, and the formula now says 49, that's our Q3, plus 1.5 times 4. Well, when we go to solve this, we know we got to do multiplication before addition. So we have 1.5 times 4, that's 6, and 6 plus 49, that's 55. That should say 55. Right there. I got a typo on that. There you go. I just fixed it. All right. So that should say 55. All right. So we know any number above 55 is considered an outlier. So I'm going to go and I'm going to look at my data set. Do I have any numbers above 55? I don't. All right. So there's no upper outlier. In this set of numbers right here, in this data set, there's only one outlier, and it's a lower outlier. It's number 34, because we found our limits right here, right? All right, we're done. Sorry, I thought I had an example for you to be able to try it yourself, but I don't, all right? There you go. If you have any questions, you can go ahead and put the questions down in the comments below. If you like the video, you can hit the like button. You can share it with your friends if you'd like to. I hope you have a great day.